Hey there! Have you ever stopped and just really looked at a single drop of water? I mean, it's something we see every single day, right? But have you ever actually wondered why it's always round? Well, let's dive into the fascinating science behind this simple, everyday thing. Right? That's the big question. When it rains, when a tap drips, that little bit of water always forms a sphere. Why not a tiny cube or a little pyramid? What's so special about being round? Well, the answer is that there's this powerful but kind of hidden force that's always at work. It's like an invisible architect that's shaping every single drop. And today, we're going to meet that architect and figure out exactly how it works. And the name of our invisible hero? It's called surface tension. This is the force, the one key player that gives every water droplet its signature round shape. Okay, so surface tension. Sounds a little technical, but what actually is it? Let's break it down. In the simplest terms, it's just a natural tendency of liquids. Think of it like a habit. The surface of a liquid always wants to shrink down and take up the least amount of space it possibly can. And here's a really fun way to picture what's happening. Imagine all the tiny little molecules inside a drop of water are like a huge group of best friends. And all these friends want to do is stick together and huddle up as close as possible. Now, let's look at what life is like for these little molecule friends. If you're a molecule smack dab in the middle of the drop, you're getting pulled equally in every direction by all your neighbors. You're perfectly balanced, totally happy. But if you're a molecule smack dab in the middle of the drop, you're getting pulled equally in every direction by all your neighbors. You're perfectly balanced, totally happy. But if you're a molecule on the surface, things are different. You've got friends pulling you from below and from the sides, but there's nobody above you pulling up. So what happens? Well, this creates a really strong net inward pull on all those molecules at the surface. And all of that pulling and tugging creates this kind of invisible, flexible skin on the water. It's almost like the drop is inside a tiny, stretched balloon that's constantly trying to shrink. Okay, so we get it. There's a force squeezing the water inward. But that still leaves us with the million-dollar question. Why does all that squeezing end up creating a sphere specifically? The answer comes down to one of nature's most basic rules. Always be as efficient as you can. State is the one with the smallest possible surface area. And this is where geometry gives us that aha moment. It turns out that for any amount of stuff you want to hold, a sphere is the one and only shape that can hold it all with the absolute minimum surface area on the outside. It is quite literally nature's most perfect container. So let's put it all together. You've got surface tension providing that constant squeezing force, trying to make the drop as compact as it can be. And then the laws of geometry step in and say, well, the most compact and efficient shape you can be is a sphere. And boom, that's our answer. But wait a second. Let's be honest. When you picture a raindrop falling from the sky, do you really picture a perfect little ball? Probably not, right? So what's going on there? Well, that's because down here on Earth, once that droplet starts to fall, a couple of other forces crash the party. You've got gravity pulling it down and air resistance pushing right back up against it. So as that drop falls, these two competing forces kind of squash it. They flatten out the bottom of the sphere, and that creates the classic shape we all know and draw as a teardrop. But what if we could take those other forces away? Well, we can. In the zero-gravity world of outer space, surface tension is the undisputed champion. With no gravity or air resistance to get in the way, water droplets form into absolutely breathtakingly perfect spheres. It's amazing. So let's put all the pieces together one last time. Let's recap this whole beautiful process and see how these laws of physics create something as simple as a tiny drop of water. Here's the whole journey in 4 steps. First, you have attraction. All those molecule friends pull together. Second, tension. That surface skin squeezes everything inward. Third, perfection. Geometry says, hey, a sphere is the most efficient shape for you. And finally, distortion. Back on Earth, gravity and air push and pull to create that familiar teardrop shape. So the next time you see the morning dew on a leaf or watch the rain rolling down a window, just remember that what you're seeing isn't just a bit of water. It's actually a tiny masterclass in physics, a beautiful, silent dance between molecular forces and the pure logic of geometry. And it really makes you wonder, doesn't it? How many other ordinary, everyday things around us are hiding these deep secrets of the universe? All we have to do is remember to look at them with the right eyes.